AI hallucination. It sounds kind of sci-fi, right? Like a computer is just making stuff up. But what if I told you it's not some weird, mysterious bug? What if it's actually something we can understand and even fix? Well, that's exactly what we're going to dig into today. We're going to pull back the curtain on why AI could be so confidently and so spectacularly wrong.
Come on, you've seen this happen, right? You ask a chatbot a totally simple question, and it gives you this answer that sounds, well, it sounds perfect. It's confident, it's authoritative, but it's just completely made up. It's got to be one of the most maddening but also kind of fascinating things about AI right now.
And hey, it's not just us regular users running into this. It happens to the very people who build these things. Get this. A researcher at OpenAI asked a chatbot for his own birthday. Simple enough, right? The model gave him 3 different dates on 3 different tries. And guess what? Every single one was wrong. That, right there, is a hallucination in a nutshell.
Okay, so let's be super clear about what we mean. A hallucination isn't just any old mistake. It's when an AI spits out something that sounds totally legit, says it with 100% confidence, but it's just not true. It's that plausibility, that feeling of, hey, that could be right, that makes them so dangerous and tricky.
So, to really get why this happens, we've got to go back, way back to how these AI models are first created. Let's dig into how these lies get baked right into the system from day one.
Okay, think of a large language model as a super-powered pattern-matching machine. That's really its core job. When it's first being trained, this phase is called pre-training, it does one simple thing over and over and over. It just tries to predict the next word in a sentence. It does this across like a huge chunk of the internet. So it's not learning facts like you and I do. It's learning the statistical probability of which word comes next. It's all about patterns.
And this is where we hit a really key point. Some things are super easy to learn from patterns. Grammar, for example. The AI can figure out pretty quick that in English, a Q is going to be followed by a U. That's a strong pattern. But what about, say, a person's birthday? There's no pattern for that. It's totally arbitrary. It's just a random fact, and you can't predict it based on the words around it.
And that is the core of the problem right there. You take this pattern-finding machine and ask it about an arbitrary fact that has no pattern, well, it can't actually know the answer. So what's it going to do? It guesses. It makes a statistical guess based on what words would sound plausible in that spot, and boom, that's where the first little seeds of a hallucination are planted. But that's not the whole story. Why did they survive?
This is where the story gets really wild, because it turns out these hallucinations don't just slip through the cracks. Oh no. In a lot of ways, we're actually teaching the AI to do it. It all comes down to how we grade them.
The researchers at OpenAI have this perfect analogy. Think back to school, taking a multiple-choice test. If you don't know the answer, what do? If you leave it blank, you get a 0, guaranteed. But if you just take a wild guess, hey, you might get lucky. The system actually encourages you to guess.
Well, it turns out that's exactly how we grade most AIs. These big tests, called benchmarks, they're almost all graded purely on accuracy. How many questions did it get right? So, for an AI, saying I don't know gets it the same score as giving a wrong answer, 0. The incentive then is to always give an answer, always guess.
Now check this out. This data is fascinating. We've got 2 AI models here. The older one on the left actually has a slightly better accuracy score, 24% versus 22%. But look at the next line. It almost never says I don't know. It only abstains 1% of the time. The newer model, on the other hand, admits it's unsure over half the time. And that leads to the really important number.
Here's the punchline. Look at those error rates. The model that's always guessing, it's wrong a whopping 75% of the time. That's its hallucination rate. But the more cautious, honest model, its error rate plummets to just 26%. It's so much more trustworthy, simply because it knows when to keep its mouth shut.
So think about that. If all you looked at was that top-line accuracy number, you'd think the older, more dishonest model was actually a little bit better. We've literally built a system with these big, important leaderboards everyone follows that can reward models for hallucinating more. We're basically giving a gold star for the exact behavior we say we want to get rid of.
Okay, so if we're rewarding the wrong thing, how do we fix it? Well, the good news is it's not as complicated as you might think. If the scoreboard is the problem, then we just need to fix the scoreboard. We need to change the rules of the game.
And the fix is pretty simple, really. Step 1, change how you grade the tests. Make a wrong answer cost you more points than just saying, I don't know.
Step 2, you could even give the AI a little bit of credit for knowing what it doesn't know. And step 3, and this is crucial, you have to update the big public leaderboards that everybody uses. That's how you change the incentives for the entire industry.
And what's so great about this is that it takes the mystery out of it all. Hallucinations aren't some spooky ghost in the machine. We can actually draw a straight line from how the AI learns with statistics right to the bad incentives we've created in our tests. We actually understand this problem.
And knowing this lets us bust some really common myths. You know, the idea that hallucinations are just something we have to live with? Nope, not true. We can teach models to say, I don't know. Or how about the myth that we just need bigger models to solve everything? Again, not really. Sometimes the smaller model is actually better at knowing its limits. And finally, the idea that we just need a new hallucination test is missing the point. We need to fix all the tests that are encouraging guessing in the first place.
So when you boil it all down, here's the big takeaway. For a long time, we've been treating this like it's some deep technical glitch inside the AI. But what this research shows is that it's really a problem with the incentives we've set up. We've basically been training AIs to be really good at taking tests, not necessarily to be honest.
And that leaves us with a really big question, doesn't it? As we keep building these things, what do we want more? An AI that's obsessed with always being right, even if that means making stuff up? Or an AI that is, above all else, honest? Honest enough to admit when it doesn't know? How we answer that question is pretty much going to define the future of this tech.